When training a model, make the following considerations. Productionizing. One should refrain from using TensorFlow in eager mode for production. TensorFlow Extended, or TFX in short, is an end-to-end platform for deploying production ML pipelines. Static or offline inference, meaning that you make all the possible forecasts in a batch using a MapReduce or something very much similar. You then write the predictions to an SS table or big table and then feed these to cache or look up the table. Do not need to be worried about much of the costs of inference. They can likely use the batch quota itself. Can do post verifications on data before pushing. That's like dynamic or online inference, meaning that you predict when required using a server. Can predict any new items on the go in the real time. Computation intensive, latency sensitive, may limit the model complexity. Monitoring the requirements are more exhaustive. Training a model as a job in different environments. The most reliable way to make sure that you train like you serve is to save the set of features using at serving time and then pipe those features to a log to utilize them at the training time. In static training, model is trained offline, while in dynamic training, model is trained online. So let us understand them in detail now. Static training. In this training type, model is trained offline. That is, we train the model exactly once and then use the trained model for a while. So it's easy to build and test, and batch training is comfortable, requires monitoring of inputs, and it is easy to let this grow on a scale. Dynamic training. In this training type, model is trained online. That is, data is continually entering into the system and we are incorporating that data into the model through continuous updates. Continue to feed in training data over time. Regularly sync and update the version. Use progressive validation, needs monitoring, model rollback, and data quarantine capabilities. Will adapt to changes. Staleness issues will be avoided. Even if you cannot do this for very example, do it for some small fraction such that you can substantiate the consistency between serving and training. Teams that have made this measurement at Google were sometimes surprised by the results. So YouTube homepage switched to the logging features at serving time with significant quality improvements and reduction in code complexity, and many teams are also switching their infrastructure as the Google has told about it. Tracking the metrics during the training. First metric is monitoring the training jobs. View status of the job using the G-Cloud ML Engine jobs describe and then the job name command. Then inspect the latest logs using the G-Cloud ML Engine jobs stream logs job name command and filter the jobs using the G-Cloud ML Engine jobs list, and you can even pass the filter argument, maybe with the condition that create time is greater than a date timestamp. Now the second metric is loss function, which is used during the training, harder to understand and indirectly connected to the business goals. Performance metric types. Confusion matrices, then the precision, which means true positive or divided by all positive predictions. When model said positive, whether the class was right. then the recall, true positives or all actual positives. Out of all the possible positives, how many did the model correctly identify? After training, it is easier to understand, directly connected to business goals, and retraining or redeployment evaluation can also be processed. Monitoring the training jobs. Depending upon the magnitude of the dataset and the complexity of the model, training can take some longer durations. Training from real world data can last many hours. You can monitor several aspects of the job while it runs. For overall status, the most facile way to check on the job is in the AI platform training jobs page on the Cloud Console. You can get the same information programmatically and with the G Cloud command line tool. Use G Cloud AI platform jobs to get the details about the current state of the job on the command line. You can get a list of jobs associated with the project that includes the job status and creation time with the G Cloud AI platform jobs list. Note that this command in its simplest form lists all the jobs ever created for the project. You should scope the request to limit the number of jobs reported. The following examples should get you started. Use the limit argument to restrict the number of jobs. Now let's take an example to list 5 most recent jobs. So you can say G Cloud AI platform jobs list -- limit is equal to 5. Use the -- filter or filter argument to restrict the list of jobs to those with the given attribute value. You can filter on one or more attributes of the job object. As well as the core job attributes, you can filter on objects within the job, such as training input object. Jobs can fail if there is a problem with the training application or with the AI platform training infrastructure. So you can use the cloud logging to start the debugging process. You can find the following resource utilization charts for the training jobs on the job details page. The jobs aggregate CPU or GPU utilization and the memory utilization. These are broken down by master, worker and parameter server. The job's network usage measured in bytes per second. There are separate charts for bytes sent and bytes received. Go to the AI platform training jobs page in the Cloud Console. Find the job in the list. So click the job name in the list to open the job details page and select the tabs labeled as CPU, GPU or network so that you can view the associated resources utilization charts.
For more details, check the link in the description. Learn with Whizlabs. Success certified.